All right. Hi, everybody. We went over this in class, but I'm going to just walk through this really quickly in the hopes that it'll be helpful to you as you continue to work on your current project and on future projects as well. So you should have access to this document, hw6.scd, in the class docs folder on Google Drive, which I shared with you all. And you'll notice I've left copious comments to hopefully, give you enough instruction in working your way through it, but I'm going to, like I said, walk through it real quickly here in this video in case my comments aren't enough. So I've already booted the audio server, so if you haven't, you'll just hit Command B, boot the audio server. Next thing we're going to do is we're going to create an empty array. We've got an empty array, we're calling it tilde buffers. This is where we are going to put all of the buffer objects that we read our sound files into. We're going to put them all into this array so that we can access, dozens of sound files really easily at the same time. Next thing we're going to do is we're going to create a path name object, which I'm just calling tilde path. So what you'll do is you'll go to the Finder window and you'll find a folder. Here I've got a bunch of folders here. Here's a folder called Wood Split, and it's got a bunch of sound files in it, just wave files, right? So this is very important. The folder that you're going to use can have nothing but wave files in it. So if you've got multiple other folders inside here, or if you've got Audacity files inside here, you need to get those out of here and put them somewhere else. Make sure you've got a folder with just sound files in it, which is what I have here. So what I can do is I can click this folder, drag it into the SuperCollider editor window, and it will generate a string which corresponds to the path name of that folder on my hard drive, and then I'll hit Command Return. Boom, now I have a path name object. And you'll recall that we can send path name objects in SuperCollider the entries message. So if I hit Command Return, this will return an array of path name objects. So an array of path name objects which point to, notice, all of the sound files in that folder. Right? And since path.entries is an array, we can iterate over it. So we can send path.entries the do message, and then for every item in this array, it will perform this function. Right? So it's going to take every item in the array, every path name object which points to a sound file in this folder, and it will read that sound file into a buffer. And it will add that buffer to this empty array that we made up on line 6, tilde buffers, right? So if I hit Command Return here, boom, now with just the click of a button, this array tilde buffers is filled with, well, buffers, right? So remember, we can, since tilde buffers is an array, we can access individual items in the array by appending tilde buffers, the name of the array, with square brackets, and inside which we will put an index number, right? So tilde buffers has, oops, helps if I spell it right, 17 items in it. So now I can send tilde buffers an index number anywhere from 0 up to 16. And I can audition these sounds, make sure they're all working there. So yeah, so I've got 17 sounds that are all read into buffers now. And so yeah, now we're good to go. We've got 17 buffers, all stored in this array, tilde buffers. So now, step 6, here on line 25, I'm giving you a couple of SynthDefs, a really bare bones playbuff mono SynthDef, and this filter bank, which we're going to use to process our sounds. So let's just verify that, hit command return. Let's verify that this synth, playbuff mono, actually works. So we're going to create a synth. We're going to assign it to the global variable x. It's going to be a playbuff mono synth, and we're sending it a couple of arguments inside our arguments array. We're sending it the bus output number 0. So this is going to get sent straight to the left speaker. And we're sending it the buffer that is at the 3rd index of our array tilde buffers. And notice we can send it any number up to 16 in this particular case, because my folder had 17 sound files in it. So index numbers for this array are going to range from 0 to 16. Right, so that works. Next, we're going to put a couple of groups on the server. We're going to create a source group, and we're going to create an effects group. We're going to make sure that the effects group is placed after the source group on the server's node tree. And we're going to create a private audio bus object, right? So hit command return there. And if you want, you can click down here in the lower left-hand corner on these green numbers, and you can click on show node tree, just to verify that, yes, indeed, we have 2 groups on our audio server. And then we're going to create a filter bank synth, right? All right, so maybe it'd be helpful if I try to explain a little bit of what's going on here. So we're creating a filter bank synth. So remember, we created this SynthDef up here, filter bank. So now we're creating a synth using that filter bank SynthDef recipe. We're assigning it to the global variable b so that we can refer to it later if we need to. So this is an effects synth. It by itself is not going to create sound. Notice up here in the SynthDef, this in.ar. So it's listening to a bus. It's expecting an incoming audio signal, and then it will process that incoming audio signal and then send it back out. So we created an audio bus, right? We called it tilde my bus right here. So now we are specifying the in argument for our filter bank synth is going to be my bus. So this synth that we just created, that's sitting on the server currently, is listening to the audio bus that we created, my bus, tilde my bus. All right, so now any audio signal we send down that bus will be processed by the filter bank synth, which we've assigned to the global variable b, right? And of course, we sent it to the effects group on the audio server so that we get our source synths and our effects synths in the correct order. All right, so there's 2 other arguments that we're sending to this filter bank synth. The first one is called freaks. So what we need to do is we need to send an array. It's expecting an array, not an integer value. It's expecting an array of 8 frequency values. So what the filter bank is going to do is we're sending an audio signal to this synth, and it's basically an array of filters, a bank of filters. All right, so it's going to resonate at 8 different frequency values, kind of like a bandpass filter, but just any energy that's sent at those 8 frequency values, it's going to resonate or accentuate those that particular frequency band, and it's going to resonate or ring for a specific number of seconds. So we're going to give it a second array of 8 values. This one is going to specify how long each of those frequency values is going to resonate or ring for. So we just need to give it 2 arrays, an array of frequencies to resonate, and an array of number of seconds to resonate each of those 8 frequencies. Right? So index 0 of this array is going to give a frequency value, and that frequency value will ring or resonate for the number of seconds at index 0 of this array. Right, so that's what's going on with this synth. So we just need to know that what we're sending it is arrays of frequency values and arrays of ring values, each of which is going to have 8 items in the array. So one way I can do that is, remember, we can do this little shortcut dupe or duplicate message by using exclamation point 8. So it will duplicate 8 times this function right here, and it will return an array. So actually, if I just highlight this and evaluate just that portion of the code, you'll notice in the post window here, it returns an array of 8 values, random values between 40 and 100. So this particular array, or rather this particular synth that we've already created, that's sitting here on the audio server, is going to resonate 8 pretty low frequencies. We can change that later. And it's going to resonate each of those 8 frequencies for a relatively long time. I mean, between 1 and 8 seconds. Let's see. Let's find. There we go. All right, let's use buffers index 2. All right. So what we're going to do now is we're going to create a playbuff mono synth. I'm going to call it X, and we are going to send the audio signal out my bus. We're not sending it straight to the speakers. We're just going to send it out the audio bus, and our filter bank synth is going to listen to the signal coming in on that bus. Right? We're going to give it a buffer number. Right? So here I can just put any item from our tilde buffers array can go here. So if you've got an array filled with 100 sound files, this is a pretty elegant way of accessing all of them. We're going to send this synth to the source group so that we can ensure that it shows up in the correct order with respect to the filter bank. And probably the most important thing is we're going to start with really, really, really low amplitude values. Since we're dealing with a resonant filter, yeah, this can get really loud really quickly. And I'm actually going to add just levels meter so we can see levels on this. So I'm down here. I'm going to create this playbuff mono synth and hit play, or command return rather. There we go. And you'll notice we got a pretty decent amplitude level coming out of the filter bank synth, even though we were playing our playbuff mono synth at a really low amplitude value. All right, so that didn't sound terribly different from the original, and that's probably because you'll remember we were resonating some pretty low frequencies. So what we can do, since we've stored this synth in the global variable B, we can send it the set message, and we can send it different values. So here I'm gonna give it I'm gonna set its freaks argument to an array of 8 relatively high frequency values. Right, so it'll return an array of 8 pretty high frequency values, and I'm going to send it an array of 8 much shorter ring times. Right, so between 1/10 and half of a second. So I'll click on this line here, hit Command Return. Boom. Now let's try playing this playbuff monosynth through tilde mybus. Again, click, hit Command Return. All right, that was pretty different, and we got a much lower amplitude level. So I'm gonna adjust this, and I can go even higher. All right, there we go. So that sounds a lot different, a lot better. So in here I can click on this again and give it 8 more random frequency values and random ring time values. So let's try it again. All right, and that sounds even different. Let's reset those values again, and let's. So that's cool. So that's one way you could do it. You could send it random frequency values, or if I wanted, I could specify specific values. Let's say I wanted let's follow the overtone series maybe from 400 hertz. So I got 1200, 1600, 2000, 2400. I just got to keep count. 1, 2, 3, 4, 5, 6. So now we need 7 and then 8. So I could specify specific frequency values if I wanted, and I'll just send it a random array of ring times, but maybe I'll make it a little bit longer. Okay, so something like that. Hit Command Return, and there we go. So let's try this again now. All right, and so yeah, that sounds different. So you'll notice, we can get pretty different sounding results depending on what we set as the freaks argument and what we set as the rings argument. Let's try it again. Oh, oops. Yeah, that wouldn't. I'm sending it resonant frequencies between 0.2 and 2.5. That's not going to sound at all. There we go. So yeah, we can fuss around with this, and we can get pretty different results. Here I'll set it to 8 random values between 100 and 3000. Right, and I can adjust the ring times. I tend to like shorter ring times on this. You get the idea. So yeah, mess around with, try different frequency values, different ring values. All right, and pause when you find one that you like. All right. When you do, open up a set of meters here, and that last one we played was pretty loud, so I'm going to turn the amplitude down even lower. All right. we go. So we want to find an output maybe a little bit hotter than that. There we go. All right, so no, we had no red on our output meter. It was pretty well in the yellow. There we go. So you just got to experiment with different amplitude values here. Once you get an output that's got a good record level, then you can record your sound. So what you're going to do is, I'm going to go back to the Finder window. Oops, not the Launchpad. And I'm just going to save this to the desktop. You could save it anywhere, but I'm going to click and drag some folder. Into this s dot as a argument into this s dot prepare for record message, and I'm going to give it a new name. All right, so I'm just going to call this new sound 1.aiff. So you specify the name of the file that you're going to record and where that file is going to be sent. So you just put in a path name here as a string, hit command return. All right, now it's ready to record. So I'm ready to record, so I'm going to hit s.record. I'm going to record my sound. And as soon as it's all done, I'm going to hit s.stop recording. So now if I go back to the Finder, boom, there it is. There's my new sound file. New sound 1.aiff. Pretty cool. So now you can take this and you can drag this into your Pro Tools session, and you can repeat this process. Experiment with different frequency values. Experiment with different ring values. Make sure you get a good record level, and experiment with different sounds from your buffers array here, right? So hopefully that's helpful. I'm sure that was more long-winded than it needed to be, but this will give you more sounds to work with as you're putting together your piece in Pro Tools. So hopefully that helps.